All right, so we did multiplying and dividing, and now we're going to do adding and subtracting rational expressions. Remember, rational just means fractions. So we're doing like some complicated fractions with some polynomials. All right, don't forget that when you add or subtract a fraction, okay, you have to have a common denominator. All right, I did a graphic organizer with a couple of problems on there. They're not the world's best problems, but they're there. I don't know if you want to download them and have something to look at. All right, so let's look a minute. If I ignore this problem just for 1 minute, if I had like 1/5 and 1/7, and I wanted to add or subtract them, how could I make them have a common denominator? I would do 5 times 7, right? So 35, because 5 times 7. Okay? So now let's look at what we have here. Let's pretend it's 1 over x minus 3 and 1 over x plus 4. They're totally different. Okay? And so if I want them to be the same thing, I'm going to do the exact same thing I did right here, which is just multiply them. Except I don't want you to multiply them out. So the least common denominator would be x minus 3 is x plus 4. Do not multiply out. Do not multiply out. You're going to hate yourself. It's going to be so not fun. And you're going to probably get some stuff wrong. All right, here. First, all right, what if we had, let me think of some numbers. What if we had like 1 over 4, and then 1 over 12. And those are my fractions I wanted to add or subtract. I could do 4 times 12, or it's really easy for me to just make this 1/4 to make that a 12, because I could do times 3. Like I could just times what's missing from this guy, because 12 is really 4 times 3. And so I could just multiply by what's missing. All right, and so the common denominator on this guy is just 12. So let's look over here. 8z minus 24. Let's factor. So take out the 8. So z minus 3. And then 5z squared minus 15z. They both have a 5 and they both have a z. So I have a z minus 3. All right, and we're happy because they both have a z minus 3. So I just write it one time. And then 8 times 5 is 40. And then a z. So this would be my least common denominator. Remember, I got the 40 because I did 8 times 5, and then a z, and then you just write what they have in common one time. All right, let's do another one. Okay, here we are. Y squared minus 2y minus 8. Y squared minus 2y minus 3. Y squared minus 2y minus 8. Let's multiplies to give me negative 8. Adds to give me negative 2. That would be 4 and 2, but 2 is negative, so 4 is negative. So that's y minus 4. Y plus 2. And then we have y squared minus 2y minus 3. So it multiplies to give me negative 3. Adds to give me negative 2. Well, the only thing it multiplies to give me 3 is 1 and 3. 2 is negative, so that means the bigger number is negative. So I get y plus 1. Y minus 3. Notice every single thing is different. So y minus 4. Y plus 2 from the first guy. From the second guy, y plus 1. Y minus 3. That's it. I don't mean something to you. I want you to learn to manipulate symbols within a framework of rules. Okay? I would never ask you, well, I don't know, I might. Never mind. All right, let's try this guy. M squared plus 5m plus 6. multiplies to give me 6, adds to give me 5. So 2 and 3, 2 and 3. So it's really m plus 2, m plus 3. Then let's do m squared plus 4m plus 4. And multiplies to give me 4. Adds to give me 4, 2. Okay, and I'm happy because I have something that is similar. So this guy and this guy are similar, so I only need to write him once. Then I have this m plus 3. So check, check, check. And then I have this other m plus 2. So since I have that m plus 2 twice, what you should really do is put a squared there. Okay. And this could be your answer. If you didn't put a squared there, then it would just be m plus 2 times m plus 3 times m plus 2. But that squared means, hey, there's 2 of us. All right, steps for adding and subtracting rational functions. So crazy fractions. Factor every denominator. I actually go ahead and factor everything. Get a common denominator. Add across. If it's a subtraction, we need to distribute that negative. We need to simplify the numerator. Factor the numerator if we need to. And then reduce and simplify again. Don't multiply out. All right, so they have the same bottoms. So since they have the same bottoms, they can talk. 3y plus x. So for example, all right, just 2/5 plus 1/5. That was our problem originally. 2/5 plus 1/5. You leave the bottom alone and you do 2 plus 1 is 3. Okay. Now it's just 3y over 5 plus x over 5. You leave the bottom alone and you add the top. And so we don't know what y and x is, so we just leave it alone. Okay, not that bad. Let's keep going. Okay, the bottoms are the same, so we'll just say 3x plus 1. This negative needs to be distributed, so it's really 7x minus 2, which is 7x minus x plus 2, because we're distributing this negative. 3x plus 1. I'm coming over here. 7x minus 1, x is 6x plus 2. Then we have that 3x plus 1 on the bottom. All right, 6x plus 2, you can take out a 2. So 6 divided by 2 is 3. Then x, 2 divided by 2 is 1. You have your sign. Then on the bottom, we have that 3x plus 1. All right, look. This 3x plus 1 can cancel. So all we have left is that 2. That's the answer, 2. All that to get the number 2. All right, that's a good problem. All right, go ahead and pause these videos before I jump to another problem since I go pretty fast. All right, so it's the same on the bottom. So I can just do 9y plus 7, 17y plus 3 minus negative 10y minus 18. Distribute, this is the fraction bar. Just sloppy. Distribute that negative. So I get 7y plus 3 minus a negative is really plus. Minus a negative is really plus. 9y plus 7. I'm coming over here. 7y and 10y. 17y. 3 plus 18. So I get 9y plus 7. And nothing can be reduced. Like 9y and 7, you can't factor anything out. And 17y and 21, you can't factor anything out. So we're done there. All right, let's try here. So m squared minus p squared, that factors to m plus p and minus p. All right, it's the same on the bottom. m squared minus p squared. And so we're just going to add the tops, m plus p. But the bottom is really m plus p minus p. And then I'm going to write this guy, m plus p. And then look, m plus p, m plus p. So I canceled this, so all that's left over is a 1. So I really have 1 over m minus p. Okay, so here on the top, on the bottom, x squared plus 2x minus 8. We need to figure out multiplies to give us negative 8. Adds to give us 2. So 4, 2. 2 is positive, so the 4 is positive, so negative 2. 4 times negative 2, negative 8. 4 plus negative 2, 2. So this is really x plus 4, x minus 2. All right, so here I have 4 minus x, and then everything's the same on the bottom. So instead of writing this guy, I'm just going to go ahead and write. What's this? Can we pretend real quick? Just pretend this really says plus. Can we just do that? Just pretend that originally said plus. Pretend this originally said plus. Pretend that was the original problem. Just go with it. All right, so this x squared plus 2x minus 8. I'm going to rewrite him now with these factors. 4 plus x, x plus 4, x minus 2. All right, 4 plus x, 5 plus 7, okay, is 12. And 7 plus 5, also 12. So you can flip-flop addition, but you can't do that with subtraction. We've talked about that before. So 4 plus x is really x plus 4. And then we have the x plus 4 from there. And then that x minus 2. X plus 4, x plus 4. And so we have a 1 left over at the top over there. So it's 1 over x minus 2 is our answer. And remember, I just changed that to plus, just like pretend that was the original problem. All right, so I'm going to stop this video, and then the next video will be with different denominators.